controlled sources. Today we understand what is the meaning of the controlled sources. Let me first define the two-port network, the input terminals, the input port, output terminals, that is the output port, plus minus, V1, V2, I1, I2. These are the conventions. You to show like this, maybe it is common base or common emitter or common collector. There are 4 variables total. V1, I1, V2, I2, 4 variables. To solve, we make 2 variables independent and 2 variables dependent. Let me choose I1, V2 as independent. Then other 2 becomes the dependent. The V1 is dependent, is a function of I1 and V2. And I2 is dependent, becomes a function of I1, V2. So total differential dV1 is the partial differentials, sum of the partial differentials, like this. Similarly, total differential of I2 is written as in terms of the partial differentials. So these are the 2 equations. When the operation over linear regions of the device curves with constant slopes, then the partial derivatives like curly I2 over curly I1, etc., they all becomes constants because the slope of a line is a constant. Then the 2 equations are written as V1 is equals to this curly V1 over curly I1 is HI, I1 plus this curly V1 over curly V2, HR means reverse voltage ratio into V2. This I2 over I1 is the forward current ratio. Curly I2 over curly V2 is admittance, output admittance into V2. This is a H parameter equation. Here HRV2 is the source, voltage source, because all terms are voltages. All terms are currents, so HF I1 is a current source. Now, what is the definition of a controlled source? It is unilateral. Unilateral means the output depends on the input. Signal is given to control source. Signal is applied to control source, and control source gives the proportional output. So signal at the output terminal does not affect the control input. So it is unilateral. So unilateral means signal at the output terminal does not affect the control input. Like for example, this is a base current. When you show base current, you show the continuous path. So this is a base current. The base current produces the collector current. What is collector current? HFE-IB. Because HFE is what? Forward current ratio. So HFE-IB is IC. So IB produces IC. So IC is equals to HFE into IB. So the voltage produces the voltage. So VA is the voltage, mu is amplification factor, mu means output voltage over input voltage. The output voltage becomes mu times VA. The current produces current, voltage produces voltage. This is the principle. Here information going from control input to output. No transmission occur from output to output back to the control input. So this is what the meaning of unilateral. Now the definition of HFE is because the forward current ratio, that means output current over input current, for common emitter IC over IB. So let me define another parameter GM, that is a mutual conductance. It is conductance, that means it is current over voltage. IC over VI. Mutual means one parameter of outside and one parameter of inside, or say one parameter of output or one parameter of input. So IC over VI, then it is divided, multiply and divide by IB. But IC over IB is what? HFE. And VI is taken to the left hand side. So it becomes GM into VI is equals to HFE into IB. So this is a very important equation to remember. Always GMVI is HFE into IB. Now we can show the voltage produces a voltage. The VI is voltage, input voltage. But you know, if you calculate GM into VI, it becomes the current. But GM into VI, it becomes the current. But you show it like this. If VI, if to show the GM into VI, to show input the voltage VI, not the IB. Because GM into VA, it is the term VA is there. Now mu is amplification factor, V naught over VA. Current. This is a resistance, but the trans resistance. One parameter outside output and one parameter input. V naught over IB multiply and divide by VA. V naught over VA becomes the amplification factor mu. IB is taken to the left hand side. So this is RM into IB. Now we can draw the circuits for the two terms separately. For the second term, the input, the voltage produces the voltage VA and like this, and current produces the current. RM into IB, there is a term IB, we show input side the IB only. So this is how we draw the circuits. So let that the voltage produces the voltage VI with amplification factor, and the output resistance is shown in series with mu times VI. Now this circuit can be converted using the Thevenin or Norton theorems. This theorem helps to convert voltage source to current source. So this is VI. Now we're going to convert it into the current source. GM into VI, GMV into VI. GM is mutual conductance, it becomes the current IC. And then series resistance comes as a parallel shunt path.